Welcome everybody to Paleo Talks. This week we are now on episode 25, so a quarter of the way to our 100 in our episode series, I guess. David, we're going to go for that 100, aren't we?
Sure. Let's keep trucking along.
All right. This week we're really happy to have Dr. Lindsay with us. Hi, Lindsay.
Hi.
And we'll get back with Lindsay in just a minute with a lot more of her background. And the talk today, we're going to be learning about mammoths from Waco, Texas. We also have Dr. Chris Widga with us today, and he's, of course, our resident proboscidean expert. So we're lucky to have him. And what did you just tell me a minute ago, Chris, about studying mammoths?
Mammoths are always a hobby. Yeah.
There aren't any experts. It's just a hobby.
Right. There may be a few, but I'm not one of them, I would say.
All right, we'll jump over to David, and he's going to tell us a little bit more about the show and how it works again.
Sure thing. If you're one of our regulars, then you know the deal. Paleo Talks is going to start with a conversation with our guest, and then our presentation today by Lindsay. And then after that presentation has been going for a while, right? 25 minutes, half an hour or so, we're going to open it up to questions from our audience. Most of our audience is here on Facebook, so if you can start at that point when we remind you, leaving your questions there in the comment section of the Facebook video. And as always, if for any reason you can't leave a comment in Facebook, you can head over to the Gray Fossil site, Twitter or Instagram page, send us a message or a comment through there. I'll be keeping an eye on those as well, and hopefully we'll fill the time with as many questions as we can.
Wonderful. Thank you, David. Another thing I will mention is if any of you out there are paleontologists and want to be on the show and you haven't been on the show yet, contact me or throw it up on Facebook if you want. Or if you know somebody out there that you think would be a really good speaker on the show, please let us know who that might be. I'm Dr. Blaine Schubert, and we are representing the Center of Excellence in Paleontology here at East Tennessee State University, where we have the Gray Fossil site out at Gray. And so we're all part of that as well. And a lot of the time we're still working from home. And so trying to keep the paleo going and get the word out with our outreach and discussions continuing. So again, welcome everybody. And let's take it over to Dr. Lindsay Dan. And if you could, Lindsay, show us your first slide.
Sure.
Go ahead and share.
All right, we good?
We're good. So if you wouldn't mind, just introduce your topic and then head right into sort of your background. We'd like to hear more about your history and how you got into paleontology in the first place. Thank you.
Thanks, Blaine. Today I'm going to talk to you guys a little bit about the Waco Mammoth National Monument and really kind of introduce you to America's Pleistocene nursery herd. I've got a lot of pictures, and I'm also going to reach out and say if any of you are interested in doing research to get in contact with me, because we have plenty of opportunities. There we go. So I was one of those people that always wanted to be a paleontologist. I think I told my parents at 8 that I was going to get my PhD in paleontology. I never really went through the dinosaur phase. I have always been in the large ice age mammals. I just find them fascinating. And thanks to the Virginia Museum of Natural History, my family and I were able to continue that enthusiasm. I then got a biology and geology degree from Virginia Tech and went on to do my master's in geology at LSU, where I worked with the late Judith Schubert and used rare earth elements to look at the source for some of our float fossils that were found in the Tunica Hills region. So got into geochemistry a little bit. And then I moved on to Vanderbilt, where I worked with Dr. Larissa DeSantis, who has been on here a couple of times. And there I did more with stable isotopes and looking at how communities and individuals respond to changing climates. After I graduated, I then went to Oklahoma State University and was their senior research assistant and volunteer coordinator for 5 years before I joined here at the National Park Service in January. Oh, and I should also mention that during my PhD, I did an internship through the GeoCorps America, which was a National Park Service internship. Now it's referred to as Scientists in the Park. So if you're a student and interested in working with national parks, check it out. But our monument, it's been around for a while, but it was not officially established as a national park unit until July 2015. And it was the 408th unit of the National Park Service.
So Lindsay,
And-
when was it actually discovered as a fossil site?
1978 was when the first bone was found.
Okay,
And I got a bit more of that to go
all right.
as we move along. But we're a little bit different park. We're a partnership between the National Park Service, the City of Waco, Baylor University, and then our nonprofit, the Waco Mammoth Foundation. So we all work together to support and offer access to this wonderful resource. So we are located in Waco. We're about halfway between Dallas and Austin along the Brazos River. So if we zoom in a little bit, our site is right at the confluence of the Bosque and the Brazos River. And today it's about, a mile and a half from our site to the confluence. But when these animals were living, it would have been much closer. So here we've got a topographic map of the Brazos River out here with our Big Bend. And then the Bosque River is the smaller one. And our site is this lovely black dot here. So T0 is our modern day floodplain. And our site is located within the T2 terrace. And we've got this tiny little lobe that sticks into the T3. If we advance, here is a closer up of our site. So we've got a low order tributary of the Bosque River, which is that white dotted line. And this is a modern low order tributary. And you can see on this map, we've got all of our sites from trenches and profiles and drill cores that really helped to identify the geology of the site. And most of this beginning bit of research is from Nort et al. 2015, and it's a good overview of the geology of our site. So the T2 is in this region, which is what we're going to focus on today. These are all of the cores and profiles and trenches that were created, and we are interested in this part here, which is the part that's already been excavated. And basically all of our sediments are a silty to clay loam, and we have lots of carbonate nodules, and we have a variety of fossil materials that have been found. So originally these were dated at about 20,000 years, but they went in and did optically stimulated luminescence dating of quartz grains around our specimens. And it turns out that our site is older than what was originally presented.
Lindsay, it might be a good idea to point out that we're looking at a cross section. Some of our viewers might not be familiar with what we're looking at.
Yes, I'm sorry. So this is a cross section of what we have today and what we think the Pleistocene topography looked like. So each one of these is an individual core hole or individual trench that the geologists dug so that they could go through and characterize the soils and the fossils and the other parts that have been found. So I didn't even think about that, so I apologize.
Yeah, no worries, no worries. When we say cross section, we really mean kind of imagine if you're looking at a slice of cake from the side.
Yes.
And these bore holes are going down, and you're seeing those slices from the side, those cuts from the side. Thank you.
So the dating of the quartz grains found two distinct layers at our site. So we've got an older layer here at 66,000 years, and then a younger layer at 51,000 years. Originally, when this site was excavated, they thought that all the fossils belonged to one layer, but it turns out that we've got a little bit more going on than originally thought. So this is just a look at our sediments, that silty to clayey loam. And we also have channel gravels beneath that cross section. And all of our bones have been found on top of channel gravels. So these would be rocks or pebbles at the bottom of a stream. And then nobody's looked at microfossils from our site. So one of the first things I did was test washed some of our sediment. And we've got 100 micron screen and 600 micron screen. And so far, we've already found foraminifera, or small aquatic organisms, in our fine fraction. And then the coarse fraction has all sorts of bone pieces and enamel or tooth pieces. So I'm hoping that with future work, we'll be able to figure out what the community actually looked like here at Waco, and not just focusing on our giant mammoths. While they are really cool, I like the idea of being able to reconstruct our entire environment. So this is what the site looks like today. This is where the original bone was found. It's heavily vegetated. The poison ivy is all over the place. But this was excavated in 1978 to about 1987. And it started off with the head of a femur or leg bone. And then that eventually turned into parts of two different mammoths, which you can see here. And by the way, they had to remove a bunch of vegetation to get down to this. But those two animals eventually became an entire layer of bone. And depending on how they're classified, it looks like there are about 16 individuals or so that are preserved. Oh no, I'm so short that I don't trigger my motion sensor.
That's okay. Lindsay, so when it was discovered, was it just weathering out of a slope or something like this?
Yeah, so there were some locals that were looking for, I believe it's arrowheads is what they were out looking for, and found a chunk of it in that low order creek, basically. It had weathered out into a little ravine, and then they were able to take that to Baylor University, and it was identified, and that's what started this whole excavation in 1978. So it's about 16 individuals, and what's really cool is that they're all female or juvenile, and juvenile we're not able to determine the sex of these. So it's considered to be a nursery herd, which is what you see in modern elephants. It is a matriarchal herd and mostly related. And which really is interesting to me is that we don't have any males, which is very different than some of the other sites that we have preserved for the Pleistocene.
Yeah, so that would be completely the opposite of the Mammoth site, Hot Springs.
Exactly. So I think that'll be interesting to look at questions in the future, comparing our isolated males in South Dakota and our nursery herd here in Waco, Texas.
So you think that they're contemporaneous then as a unit?
Yes. So they've dated from different sections of the unit, and they're all within that 68 to 68 plus or minus 5,000 years. But as of right now, I mean, I haven't seen the nursery herd material. This stuff was all removed in the 90s, I believe. But original notes suggest that they were deposited at the same time.
Okay.
So there's plenty of work that we still need to do, though. But after those jackets were taken out in the 90s, they had to take in a backhoe and like regrade the ground because they were having so many flooding issues. And in the process of regrading, they came across more bone. So this is our second excavation, which was done from about 1990 to 2002. And this is where we find our first male mammoth. And I'll give you an up close look at him in a little bit. But you can kind of see the original nursery herd layers down here. And we've got different layers of sediment between the two different fossiliferous layers.
Maybe, Chris, you could comment on this. Are there other herds that we actually have out there in the world of fossil proboscideans where you think it might be one time frame, even one possible event?
Well, I mean, Lindsay could talk to that for sure, but there aren't a whole lot of things that come to mind. We do get lots of mammoths in one place. Lindsay, what are you thinking on that?
There is, I'm blanking on the name, but there's a site in Idaho that is, looks like it might be part of a nursery herd. And that's the only one I know of off the top of my head. I'm sure there are others, but.
Well, the fun thing about that is that you're testing an ecological or a biological hypothesis. And, you run into this a lot with paleontology. Is it something where these animals came in at different times and they're averaged together, or is it a single biological population, which is really a fun question to ask?
And it becomes a little bit of a sticky question, being as we are national monument based on a nursery herd. So future research will be fun. I'm looking forward to it.
Yeah. Well, the Gray Fossil Site, we're getting a number of mastodons in one location. And of course, the growing idea is that maybe this was an event where we had captured several individuals. And these, of course, are 5 million-year-old mastodons. So we're not saying that's what it is yet, but we're looking at it with very curious eyes.
That'll be interesting as that progresses. But these fossils were pretty much exposed to the elements for 15 plus years. They had a lovely circus tent covering them, but now we've got a dig shelter, state-of-the-art dig shelter, climate controlled, humidity added. Our fossils stay at about 70 degrees and 50% humidity year round. So this has been a wonderful place to work and preserve our fossils. So this gives you an idea of what we're looking at inside of our dig shelter. So I mentioned that the nursery herd was excavated removed from the ground about 1990, 93. But this is the second phase of excavations, and it's been preserved in situ or in place. And what we've got here is a catwalk that goes through and it allows visitors to look at our mammoths from above. And the catwalk is suspended from the ceiling, so we're not causing any extra damage to our fossils. So we've got our male mammoth in the middle. We've got another individual down here, and I'll give you all sorts of close-ups here in a minute, but we also have a camel, which I'm a little partial to. And we've got a female. So we've got a little bit of everything preserved within the dig shelter, but it doesn't tell the entire story. This is Mammoth W. So all of our individuals have a letter name. When they were first identified, they sometimes use letters, sometimes use numbers, but pretty much now it's converted to a letter system. And we have Mammoth Z preserved as well. As we start to go through the collection, it may turn out that some of these individuals are actually two individuals become one. So we're still working on how many mammoths we actually have at the site, but in the ballpark of 20 to 23 is kind of what we're looking at right now.
Now, is the collection there on site?
No, so our collection, it was originally housed with Baylor University because that's who identified the material and who collected it. We're in the process of transferring ownership over to the National Park Service, but Baylor University will remain our repository. So all of our fossils will be in one place, which is really unusual, but it's, I don't know, maybe a 3 or 4 mile drive from the site to get to the specimen. So it's very convenient, and it's really nice to have all of our material in one spot.
All right, thank you.
But our collection of fossils, we've got all sorts of things. I'm going to start with a couple of our adults, which are some of our more impressive specimens. Again, this is Mammoth W. We have her pretty much entire skeleton, so we know she's a female based on her hips. And she has the prettiest teeth in our dig shelter. So she is the one that when we need to talk about how these animals ate and what their teeth looked like, we always go to her to point that out. But this is our prized possession, I guess. This is Mammoth Q. He's our only bull mammoth. And he's in that top younger layer. So he's about 51,000 years old. And he died at about, we think, 45-ish, 45 or 50, based on his teeth. But he is nearly 85% complete. So we've got a lot of information that we can get out of the skeleton. But what he's missing are his lower legs and his feet. He's got some of his front toe bones, but most of those are missing. Pretty much everything else is preserved. We've got these wonderful tusks in the front to orient you. So tusks, here's his head. We've got ribs coming along, hips, back legs here, and we're missing the lower part of his back leg over here.
Well, Lindsay and Chris, one of the things people may be wondering about is, how do you know a male mammoth from a female mammoth?
So, if you look at the pelvis or the hips here, we've got a nice big circle. I don't have a picture of Wanda's or Mammoth W's hips, but hers are much more diamond shaped. So the shape of the hip is really the way that we're telling the difference. You can also use size, I would imagine, but the hips are our go-to. And of our juveniles, they're not developed enough to determine whether they have a circular or a diamond-shaped pelvis, so we're still unsure if they're male or female. I don't know if Chris has anything to add.
No, that's exactly what I would have said, Lindsay. There's some sexual dimorphism in the tusks as well,
Yes.
And certainly in general body size. Looking at this picture, one of the things that really strikes me is the tight articulations. I mean, there just hasn't been a lot of movement of this skeleton and smearing of this skeleton. And I don't know if you're going to talk a little bit about that in future slides, but are there ideas of how these animals died and then ultimately why they were preserved in kind of these as skeletons and not smeared around very much?
There's quite a bit of difference in the articulation of our skeletons. He is by far our most complete and tightest articulation of all of them. And there's kind of two ballparks on what happened and why they're there. Basically, the sediment is so fine-grained that its previous interpretations have been rapid deposition and burial. There are some things from like mass wasting events with flooding, which is very common in this area today. But there's some features on the surface of the bones, which I will show a little bit more of, that suggest that that might not be the case. And we really don't understand why they're so well preserved. So that's one of the things that I need to bring in researchers to do so that we can actually figure out what happened to these animals between death, burial, and finding them in the 90s. So we've got a lot of work ahead of us.
So is it thought to have been a watering hole then?
A water what?
A watering hole where they
Yes.
were coming? Yeah.
So that is the interpretation right now, is that it would have been a regional water hole and brought in animals from all over. And I know that one study looked at stable isotopes, and they can see that we have at least our mammoths were traveling from Austin to our site. So it seems to be a regionally used water hole. Again, I don't know if there is concrete research that shows that, but that is kind of the hypothesis at this point. So we also have the juveniles. And what's really cool is we've got these epiphyses or growth plates preserved here. So we've got a femur of an individual, and we've got all different little growth plates throughout this fossil. So we can really tell that this animal was still growing. And it doesn't look like we have any evidence of babies at the site, but we do have these juveniles. And then this one here is another juvenile that's up with our younger layer, that bull mammoth. So we've got juveniles and adults in both layers. We see bite marks on both fossil bones from both layers. So this is Mammoth Q, our big bull, and there are bite marks along his femur and along the patella. And we see this multiple places on him. But we also see some smaller scale bite marks. So this is a rib from the original nursery herd. This is one of the fossils that I've been working on since I started. And we can see these parallel grooves here. We see that on many, many of the ribs within the nursery herd. So we're seeing some interaction of these carnivores and the environment. And I really like the idea that we can use that to create a picture. These are not just rocks laying in the ground. We can really create a living, breathing picture of what Central Texas looked like during the Pleistocene and these interactions. But we also have some pathologies. So we have injuries and regrowth within some of our bones. So our big male mammoth, this is one of his ribs. It should be a nice skinny rib, but you see this giant, it's about a softball sized thing in the middle. So we know that he broke his rib and it started to heal. It got infected and it continued to grow. The bone continued to grow and it was not what caused his death. So we've got little tidbits of information like this that we can use. We also have snapping turtles, and we see shell rot on some of these snapping turtles. So we got a researcher that is coming in to investigate why we may have shell rot and what that might tell us about our site. We also have quite a bit of fracturing. So these breaks are not things that were caused by the people that excavated the bones or the equipment or anything like that. These are fractures that happened near death. So sometime shortly after these animals were buried, we see spiral fractures and just crushing. This is Mammoth Q's shoulder blade or scapula. And then we see the same thing. This is also Mammoth Q. We see fracturing on quite a bit of our individuals. But what's really cool about Mammoth Q, this is his skull. It's kind of hard to tell because there's a giant round depression in the middle of his head. And it turns out that this is about the size of a mammoth footprint. So it looks like sometime after Quincy died, or Mammoth Q died, he was stepped on. So we're curious to see how much of the nursery herd shows evidence of trampling. But
this is extraordinary getting to see this, because I've thought about this a lot in working at Saltville in, what happens when a mammoth that's walking around in the mud steps on another, or a mastodon steps on a proboscidean, and how does that bone fracture? And here we are. I think this is a great example of that potential.
Yeah, and we've got, just on this one individual, there's a spot on his shoulder blade and maybe some ribs that are all roughly the same size and shape. Nobody has looked at it.
I wonder, because I would think that this would be sort of in the mud or in the muck or underwater in this situation. And I wonder if you at that same time don't get scavenging on those exact remains because they are sort of underwater.
Well, he is missing his lower limbs, which are first to go, but the rest of him is pretty much there. So
Interesting.
one interpretation is that it was a diminished watering hole and it was a severe drought instead of being a mass wasting event. So there's still some discrepancies in exactly what happened.
Looks like Chris has something to say.
Oh, I was just going to say, yeah, this is fascinating because, I mean, one of the things that is kind of our standard understanding of elephant watering holes with modern elephants in Africa is, you know, you have this manipulation of bones, and you get broken tusks, and you get broken bones, and things like that. So there's kind of a modern analog for this that we can test against, which is fun. That's one of the neat things about Waco.
I'm looking forward to learning a lot more about elephants and their behavior, something that I don't have a whole lot of experience with.
They're extremely long-lived and complex animals.
But yeah, there's no reports of crushing like this on the nursery herd, but most of this material is still in jackets. So as we start to go through and prepare this material, I'm really curious to see if we're seeing the same exact things happening at our lower level and our younger level. Is this an environment or a event that kept repeating itself through time? So that is one of the things that I'm interested in looking at as we go through these. So most of our bones are mildly weathered, not terribly bad. They would be the stage 1 weathering from some of the previous work that's been done in Africa. But we do have some bones that are preserved that show stages 2 and 3. So it's questionable whether everything was rapidly buried or whether we had some of this exposed at the surface for extended bits of time. But we also have traces like rodent gnaw marks. This is hypothesized to be from a dermestid beetle eating the fleshy bits off of Mammoth Q. And then we have root traces all over all of our bones. They're very chalky bones, and nearly all of the surfaces are covered in some form of trace. So this is a Karen Carr reconstruction of what we think that the Pleistocene might have looked like here in Waco. We've got mammoths, we've got, one thing I didn't show was we have a juvenile deciduous tooth from a saber-toothed animal, cat. We don't know if it's Homotherium or Smilodon. We have plenty of camel material as well, and as we go through and better understand these bite marks and other traces, and then hopefully look at our microfossils, we're hoping that we can better adjust this interpretation. Because some things that you don't see in this reconstruction are, we had turtles, definitely had red-eared sliders, we had a snapping turtle, and we had giant tortoises. So there's still a lot more that we don't know about what Texas looked like in this region 65,000 years ago. And having a background in stable isotopes and paleoecology, this is something that I'm really interested in. It's like, how can we better understand the whole community and what was going over time? So that's one of the things that I am looking forward to. But the other thing is, like I said, that we are looking for people to come out and help us do research. So if there's something that interests you, contact me. We have a permit system. They all go through the same NPS permit, but I am the one that approves permits for Waco. So reach out to me. We've pretty much, you can ask any question you want. We don't have much published literature, So we definitely need other geologic studies. We need archaeological studies. We would like to do biological surveys as well. Our microfossils, very little has been published on the body size and age estimates of our individuals. And there's a lot of information we can look at for comparisons between our site and the South Dakota Mammoth site, potentially the one in Idaho, and the new finds in Mexico. And then lots and lots of geochemistry. So some of the isotopes have already been done, Grant. We've looked at, or not we, previous researchers before I started here, looked at strontium isotopes to figure out how far these animals were moving, and looked at the carbon isotopes to figure out what these animals were eating. So we can really go in and get more specific on what these mammoths were doing and what the environment might have looked like. But that's basically what I have. It might have been a little bit short, but
No, that was perfect timing.
awesome, great.
Right. What we'll do is we'll jump over to David, and he'll ask a couple of the Facebook questions that have come up, and then Chris and I will chime in as well with questions.
Perfect.
All right, so like we said at the beginning, at this time, if you haven't asked your questions already and you have some burning questions for Lindsay, go ahead and start putting them in the comments of our Facebook chat. If you can't comment on Facebook, head over to the Grey Fossil site on Twitter or Instagram and send us questions there. I'm going to start, since you, right there at the end, you touched on some of the other aspects of the assemblage there. Melissa Party is here in the comments, and Melissa wants to know, what else is preserved there? Are there smaller vertebrates? Are there plants? What else is known about the smaller fossils?
Right now, nothing is known about the smaller fossils. Nobody looked. So in the original excavations, those were headed by archaeologists. So I think that the sediment was all screened at maybe a 1/2 inch and 1 inch screens. So nobody looked at the finer material. I don't think there's been any plant material uncovered. At least there's nothing that I know of. Potentially a hackberry phytolith. Turtle, tortoise, camel, saber-toothed cat, mammoths. There's potentially a coyote paw also in collections. With COVID, I haven't really been able to go and spend time in collections, so I'm relying on the database.
So Lindsay and Chris, with you're saying that the archaeologists are the ones that had originally excavated. And I'm guessing, because I have never really read up on Waco, that is because it was thought to have been younger and archaeological and maybe a kill site? I don't know.
Yeah, that was the original interpretation, is they thought that they would be able to find evidence of human hunting, because it was originally dated at 22 or 24,000 years ago. But since then, the date has been revised, so I don't think we're going to have any humans.
Okay.
Yeah, I think that's an excellent thing to always point out about these museums where you have ongoing research too. You're constantly learning. There's new techniques. I know that original date was on bone carbonate, and so it wasn't very reliable given our modern standards. And so I know you mentioned some of the dates in your talk, and they're beyond radiocarbon. And so can you maybe talk a little bit about how you got those dates?
Sure. So it's a process called optically stimulated luminescence. So quartz grains were collected using a lights. It bothers me. So the grains are kept from light, because what you want to basically do is look at the radiation and figure out the last time that those grains were exposed at the surface. So this was work that was done by Steve Foreman at Baylor University. And that radiation difference is what they use to date those grains. So we actually don't date the bones themselves. We're dating the sediment that is around the bone, or inside their skull. We tried to, they tried to get as close to the specimens as possible, but that technique is a little bit limited for figuring out exactly how old one bone is.
Do you know if anybody's done any analyses to see if any collagen or other bone proteins are present?
So there were at least one unpublished work that looked and did not successfully find any. I don't think anyone else has come back, and that was in the 90s maybe. So I don't know if techniques and
Might be
methods
time
are
to check
better.
again.
Yeah.
Okay, David?
Sure, we've got a couple more questions. We had a couple of questions about dating, which have been answered now. And we've got a couple other questions about the assemblage before we move on from what is found there. Alton asked about Homotherium. I know you mentioned possible Homotherium or other carnivores. Do you know anything about other carnivores at the site?
Blaine and I were talking about this a little bit before we started. Right now, there is no direct evidence for other carnivores, potentially that coyote paw, if it's correctly identified. But some of the bite marks make it look like there were other carnivores scavenging in this area. We just haven't found direct evidence of it yet. But the entire collection hasn't even been inventoried, so there are still hidden things that we may be finding in collections. So I'm hopeful that we will find more carnivore material, but right now it's just that one juvenile deciduous tooth.
Oh, and that's a fun question too, because in Texas you have Friesenhahn Cave, this example of Homotherium, the scimitar cat, basically preying on baby mammoths. And if you have a baby mammoth herd, a nursery herd at Waco, it'd be fun to find this big carnivore.
Yeah, exactly.
Good luck.
Well, we do have some unknown ribs in the wall within our dig shelter, which were found with the juvenile tooth. So we're wondering if we continue on excavating into the wall, if maybe we'll find some of that cat.
A kitten.
Mhm.
Well, it was not a kitten. It was a couple few years old.
Okay.
So the tooth is fully developed, and the adult canine had already started to erupt. So we know it was a little bit older than that.
Got it.
Speaking of fun questions about the animals at the site, Gino asks, is the Columbian mammoth the only proboscidean found at the site so far?
So far, yes. I have not seen all of it with my eyes. But all of the notes and everything suggest that it is all Columbian mammoth, which makes sense. It is the southern species. So.
Gotcha. All right, we've got a question from Greg, who asks, do you expect different REE signatures in the bones from the two different levels?
So, based on my master's work, that's one of the questions that I want to tackle. I don't know when and where, but it's hard to tell. So, they think that the original source was the Bosque River, and that probably hasn't changed. So, it was all
Lindsay?
basically draining the same area.
Just take a moment and describe what Greg is talking about.
Okay.
That question.
So rare earth elements are those elements that are at the bottom of the periodic table, and they are about the same size as the element calcium. So as water flows through these bones, that calcium can be replaced by these rare earth elements. And then what you do is you go in and you look at the profile or the concentrations of these particular elements. And then you compare that to another deposit, another layer, another site. And what you're doing is seeing whether or not those profiles are the same or different. If they are the same, it would suggest that they were both fossilized with water and minerals from the same general drainage area. If it's different at our site, that might suggest that at one time the Bosque River had more influence, and then at another time the Brazos River had more influence. So there's the potential.
It tells you whether or not two are the same, right? Not necessarily what the age is.
Right. Yeah. It's not. It does not work for dating at all. It works for looking more at the source of the pore water, or the water in the sediment.
Well, and that actually brings up kind of a question that I had. So if you're kind of talking about a shift in the drainage pattern, kind of this local shift that may influence your chemical signature in the bones. And as you're talking about this stuff, I mean, I'm thinking about Central West Texas, and I'm thinking about playas, and I'm thinking about these short seasonal, drainages that don't have a lot of water in them. I mean, do you have any feeling at this point whether it's kind of one of these playa ponds and it's just a seasonal concentration of mammoths, or is it something that you are getting more of this Bosque River kind of a predictable water source throughout the year?
Based on the research that's been done, it's more of a permanent or semi-permanent water source. We're not now, or in the Pleistocene, nearly as dry as West Texas. And being so close to the rivers, it appears that there is a pretty constant supply of water. We do have carbonate nodules, and we have a caliche layer. So it was drying out some, and we haven't found the center of it, so we don't know if it was just kind of shrinking and expanding or disappearing altogether.
We got another question from Facebook. Dick asks, do you have any footprints from the site?
Not that I know of. The closest would be the potential one on Mammoth Q's head.
Which I'm sure would be a lot harder to recognize than a footprint in sediment.
Yes, and we don't see any, at least right now, since this was excavated, and the excavation stopped in like 2002, so they could start building the dig shelter. All of the exposed sediment, like over here, you can kind of see layers, have been filled in with just dust and debris over time, so we're not getting a good picture of what the stratigraphy or the sediment layers look like. But there's nothing in the notes that suggests that there were like soft sediment deformation or wavy lines within our sediment suggesting that a mammoth foot got kind of stuck in soft mud. So they might be there. There's just right now no evidence of it.
Are you gonna plan on cleaning up some of the profiles to look at them and see if you can see any of the swirl marks that you might get?
We haven't figured out exactly what strategy we're going to take within the dig shelter, whether we're going to leave it the way it is or continue doing some excavations within. But there are, what they're referring to as witness columns within the dig shelter. So if we can clean up some of these small columns, it'll allow us to connect the stratigraphy or the layers throughout. So I'm hoping that there are a couple of spots that are less or more stable, that we can go through and dig another trench in and really document some of this. So hopefully, yes, down the road.
All right. Back on the topic of the taxa that have been found. Mason asks if this is a watering hole. Are there any fish fossils?
Yes. So I realized that I had forgotten an entire group of animals. We've got the turtles and the tortoises, and we've got gar fish in the form of scales, I believe, drumfish teeth. Those are the only fish fossils I know. There is a note that suggests maybe catfish, but I don't know how reliable that identification is. So yeah, we definitely had fish. So we had a a body of water for some period of time. I don't know what layers the fish came out of, whether it's the younger or the older layer. A lot of the stuff is collected as float during, well, like when it was exposed at the surface for 15 years in rain, washed out a bunch of stuff. So I don't know what layer contains our aquatic animals, but we do have aquatic animals.
Very good. And then Grant has asked, this is Grant Zazula, Northern Grant, as the Grants have dubbed him. Grant says, I also wonder if oxygen isotopes could help you determine if those pore waters are from interglacial or glacial or interstadial intervals based on climate or temperature reconstructions.
So this is another one of those projects that is very similar to some of the work that I did with my dissertation. And I think that we might be able to do that, and a little bit of work. I think there's been one value published or two values published. But I'm hoping that we can look at that in the future, because I think it might be an interesting story to tell and bring in. They think that this was a period of high aridity for the region based on, there's some, I think, speleothems or cave deposits that also suggest high aridity. So I'm wanting to look at our mammoths and the other taxa and see if we can figure out were we in a period of aridity, and can we kind of place that within time?
Very interesting. Other Grant, Southern Grant, Boardman, has asked, this is a question about a different site. Grant says, hey, Lindsay, have you gone back to look at that Tunica Hills Hempilian mastodon we excavated at LSU?
Not lately. There's so much I need to go back and look at. There's a lot of fun work in those Tunica Hills specimens that we got, but I have not been back in 5 years, 6 years.
And that actually kind of closes the loop back to the gray fossil site, because I know as we've been excavating and looking at our mastodon, as it's been coming together, that Tunica Hills mastodon is really, really interesting because it's about the same time period. It's the same kinds of animals that are with it. It makes me want to know more about it.
Yeah, I wonder too, I mean, thinking about these from other sites and some of the recent projects, and with the Mammoth genetics project that happened, in recent years, Chris, do you know if they tried any of the Texas mammoth specimens?
Jake did not go to Texas. So what Blaine's talking about is basically a couple of years ago, there was a big ancient DNA project looking at mammoth DNA. And before this project, we thought there were 4, maybe 5 species of mammoths in North America. You had pygmies on the Channel Islands, you had Columbian mammoths, you had woolly mammoths, you may have had this other thing in the Midwest called Jeffersonii. And what this, it was a PhD project, and what this Jake Hank had done is just start basically in the Midwest and then start traveling west, ending in California and the Pygmy Islands, or the Pygmy mammoths in the Channel Islands. And the results of that were really interesting. So found that genetically, these different species aren't really that different. Even the Pygmy mammoths weren't horribly different from Columbian mammoths. But I remember as we were kind of pulling together the final report on that, one of the things that was really difficult to tease apart was, do you have some sort of woolly mammoth intrusion that basically swamps all the DNA of everything else late in the sequence? Or if you went further south, would you get more of a pure Columbian signal? Would you get more of a kind of a deeper, native Columbian mammoth signal? And it sounds like, Waco mammoths would be something that would be really interesting to chase.
Great. David, are there any other Facebook questions? And if not, can you go over to the Zoom grad student group?
Sure. Yeah, I'll start asking some of these student questions. So these are from our grad students who are tuning in to the talk as well. Julian asks, is there an age range for the other adult mammoths at the site? At what age did they become reproductive?
So we've got one female that is 60 something, the matriarch. And then most of them, I think, are in the 20s. As for becoming reproductive, maybe Chris has an answer, but I think it's 6 or 7.
Yeah,
I'm not.
I think late first decade, early second decade.
Okay.
And I'm sure if I'm wrong, then the Facebook comments will light up.
Yeah.
One of the things to maybe talk about just a second is that, you know, they don't come with their date stamped on them and how old they were when they died. And so, you know, how do we figure this out, and how do mammoth teeth erupt, which is just weird.
They are very weird. So at any given time, a mammoth really only has 4 teeth in its mouth if we ignore the tusks. And as they wear those down, they have rolling eruption. So the next molar is kind of pushing forward. It pushes that worn molar out, and that way it keeps the chewing surface available for these animals. And they've got 6 sets of teeth. So once they finish wearing down their 6th set, they're kind of out of luck. But in order to figure out how old they are, we can look at the number of enamel loops that are on the surface of the tooth and use that to figure out the animal's age.
And what does a 60-year-old mammoth look like with his teeth? It must be just sort of gums at that point.
Not really. Well, we only have a cast in the dig shelter right now, so I haven't seen the actual tooth, but it looks like she was still going strong.
Okay.
All right, I'll go ahead, and as we're sort of nearing the end of our time here, here's another question from one of our students. Christiane asks, in reference to the bite marks that we were looking at before, do those bite marks imply that rapid burial didn't take place directly after death?
Yes. So that is one of the issues that different research groups have here. If we've got scavenging and bite marks, it would suggest that they were exposed to the air for at least some time, whether it was just the rear legs of the animal or the whole animal was exposed at the surface. We're not really sure right at this point. But for scavenging to occur, they had to be on the surface for at least some time.
Yeah, that's a really important point, is that, especially with something as large as a mammoth or a mastodon, is that part of it could be buried, part of it can be buried, and other parts can be exposed.
Yeah,
which is what we think with Mammoth Q, our big male, that likely his hind legs weren't buried.
Yeah, that's one of the really fun things with proboscidea and taphonomy is, you know, with taphonomy, with how these big carcasses decompose and kind of are, oftentimes it's a multiple year, sometimes even as much as a decade kind of process, and things change. So, and things change in weird ways. So you have this armored, dried out skin that may limit access to parts of the carcass, but then you have other ways in through, holes in that skin or whatever. So this would be a really interesting avenue of research in the future. So that'll be fun.
All right, well, we are just about at the end of our time here. So Blaine and Chris and Lindsay, if there's anything else you want to say or ask before we wrap up, now I think is the time.
Lindsay?
Thank you for having me on here. It's been a lot of fun. I appreciate all the questions.
Thank you so much. I've learned a lot and just fascinating. The taphonomy I'm going to be thinking about all day, I think.
It will keep you awake at night. Yeah, this is a really neat site for taphonomy.
Yeah. Well, thank you again, Lindsay. And thanks everybody for tuning in. We'll see you next week. We're going to talk a bit about turtles. All right. Bye-bye, everybody.